Hi everyone. Welcome to the Docker workshop by the Data Science and Machine Learning Club. My name is Raghuir, and I'll be getting you along to the workshop. So the agenda for today is that first we'll be going through Docker basics, and we'll also be running our first container. And after that, we'll be building our own Docker image from a Docker file. After that, we'll have a short break. And after that, we'll talk more about Docker networks, Docker volumes, and also we'll be deploying multi-container applications using Docker Compose. And at the end of the workshop, we'll also be deploying our very own LLM, like similar to ChatGPT, using Docker on Render, which is like a small cloud platform. So we'll make a publicly accessible URL. So what we hope to accomplish by the end of this workshop is that we'll be building our very own Docker image, and then we will learn how we can save this Docker image and how we can share it with others. And also, from after you save the Docker image on Docker Hub, how can you deploy that in different cloud platforms? So we'll be using Render, but you can follow a similar process to deploy it on Azure, AWS, or any other cloud platforms. And after that, once you do the deployment, we'll have a live public URL, which you can put it on your resume, you can put it on your portfolio, you can share with your LinkedIn. Uh, okay. So let's start about what is Docker. So Docker was a platform. It was mainly created for developing, shipping, and running your applications inside containers. So what is a container? So a container is actually a self-contained unit. So everything like all your application, your dependencies, and your runtime, like similar like Python runtime, and you have Java runtime as well. All of this is in a single package, and it's basically the Docker image is a blueprint for this. And once you run it, it runs something as a Docker container, which is run on the Docker engine. So why do we need Docker? So I think we all face this problem. We have built a really cool application, and after that you share the code with your friends, and then what happens is it's not working anymore, like it's not working on the machine. Maybe they don't have the same operating system, they're running on a Mac OS instead of Windows, or they have a different version of Python. So you might be using Python 3.10, they might be having Python 3.11, so the application is not working. So what happens is that um, it leads to some frustration. I face this issue that I have to spend some time. I need to understand what they've done in their code. I need to install the libraries again. If it's a different library, I need to reinstall the library again, and only then I'll be able to. So it leads to a lot of like time waste and a lot of frustration. So what Docker does? So what happens is Docker, it ensures that it is consistent. So whether you have a development environment, whether you're in testing or production or it's on a different machine, it still works. And it is also lightweight. So you can see that if you're running it on your laptop is pretty powerful. It has like 16 cores, but many applications don't need so many resources. So what you can do is you can isolate those resources and you can run it in its very on small environment, and also portability. So what happens is, suppose you have a container and you build something. So suppose you want to move it, it will be very easy to move this particular container from one system to another. Like suppose you want to move it from a laptop into your friend's laptop, or you want to move it to a server in the cloud. That's why we need Docker. So how does Docker work? So basically, there's something called as a Docker daemon. That is a Docker software which you install. So this basically Docker daemon is, in simple words, it's like a program which is running in the background. So what happens is you build your image, like you have an image. So Ubuntu as an image, Python as an image. So what happens is once you build that image, what the Docker daemon does is that first it will check whether, like the program will check whether the image is there on your particular laptop or on the server. If it is not there, it will go to the registry. Like it's like something like a repository, like something like GitHub for images. It will pull that image and then it will run that image in your laptop, and you have a working application in a couple of minutes rather than a couple of hours. Yeah. So the Docker Hub. So it is a cloud-based registry. There are other registries as well. So if you're working for like a big company, they'll have their own private repository in AWS or in Azure. But the Docker Hub, right? It is like a public, like I mean, it's a public repository where even all of us can create accounts, all of us can upload our images, and all of us can share it. So just to show you, I'll just open up the Docker Hub. This is the URL for the Docker Hub. You can. So here you can see that Docker Hub has they have images for TensorFlow, PyTorch. So everyone, I think, whoever is working with machine learning and data science, they know how long it takes to install PyTorch. It takes like 15-20 minutes. So you can just download the image and you can get started within seconds. And even if you see, they have images for databases like Postgres or MySQL. So you don't need to do a lot of configuration. All most of the configuration is done. So you can quickly spin it up within a couple of minutes. So we'll be running databases also. So yeah, so we'll be running our databases as well. So I'll just show you how we can do that as well. Yeah. So everyone, all of you would have got a particular slip like this one. So in this, you have okay, yeah. Yeah. So all of you would have got a slip like this one. So here there is a URL here for a code server. If any of you have Docker installed on your laptop, you can just go ahead and use it. But we have already created some virtual machines. If you would like to use that, um, just there's something called code server and there's a small HTTP URL. You can just put that into your browser. Um, I'll do that as well. And there should also be a password also on that small slip. So it'll ask you for a password. And I'm sorry for the password. I mean, it's really complicated. Yeah. So till now, with whatever we have covered, does anyone have any questions? Okay. Yeah. Yeah, it is cost. So, I mean, I'm hosting it in GCP, but Google Cloud compared to Azure and AWS, they're pretty generous. So we get around $300 in credits, and that's available for 3 months. So that is what we are using. But to push your Docker images to Docker Hub, it doesn't cost anything. So it is yeah, that's free. And even render as well, where we'll be deploying it later, that is also free up to a certain limit. Yeah, I mean, yeah. And if you're running anything on a laptop, that's free. I mean, it's all open source. Docker is open source. So even for enterprise solutions as well, if they're using Docker, it doesn't cost them anything. So yeah, once you put in the password and the URL, you should get something similar to your VS Code here in the cloud. I mean, I like the dark theme, but yeah, you'll get something similar to this. You should be able to get. If anyone has any issues to reach to this point, just raise your hands and we'll come and help you out. Fine. Yes, give them another slip to dive in the. That's what I will do. Does anybody raising any issues? This here. No. You just need the code server, the URL, and just a password. Put that 136. What's it very good? No, pretty sure it's not good. Huh? 37, 34, 71, 134, 25. System and video and then go on job. Get the speed up. Two down. Another one good. Where is it? I don't know what that is. ये मेरा चल रहा है and for me it's working. This one is also no, I mean, I think that single system. He could not be I get when I just have a you just close what you got. So, did everyone reach up to this point, or is anyone else still? Still up. Maybe something on the internet is it? How many of your suit facing industry? No. You're not having just sense of all this system. My expert, come on, it's not like really find I don't know. It's okay. I mean, good time. Right, this whole. Hmm. Yeah. Let's start. I'll proceed. Yeah. So once you're inside this particular like Visual Studio Code environment, you can click on this Explorer button here, and you can click Clone Repository. And Vicky, did we share the URL for the repository with everyone? Just Teams chat. Yeah. So I've shared the URL for the GitHub repository. So you can click on this Explorer icon here at this corner, and you can click on Clone Repository, and you can put in the URL here. And once you put in the URL here, just click Clone from this particular URL. It'll ask you for a destination, but that doesn't really matter. You can just set the default, like the home location, as the repository destination. And after that, you will get an option. Would you like to open the cloned repository? So you can click yes, you can open it. And it'll ask you there'll be a small message where it'll ask you whether you want to trust the authors. So you can just go ahead and you can trust the authors. And after that, you should get the files here on the left. Everyone get the URL. Yeah. So what we did is you just click on this little like the file icon here, and once you do that, there'll be an option to clone the repository. Once you click clone, you put the URL clone, and then just set the directory. And then if you just once you click OK, you should it'll ask you to open in the same window. Once you click open in the same window, you'll get uh, a message asking whether you want to trust this author. And once you do that, you should get the code right. I mean, you should get all the files right. Okay. So let's start with module one. So what we can do is just click on the hamburger icon on the top left. There'll be an option for terminal, and and you click on new terminal. So you should get a terminal window at the bottom. And then you can open the exercises here as well, so you can easily copy paste the code into the terminal from here. So first what we'll be doing is we'll be running a simple like for every programming we've learned a new programming language. uh, the first program everyone learns is like the hello world program. So even here for Docker as well, there's a hello world image. So what we'll do is we'll just do this just to check if Docker is installed correctly on our virtual machine and whether everything is set up. So to quickly check, you can just do Docker and hello world. So once you do this, you should get uh, a message like this, a hello from Docker. So yeah, could you please give this a try? So let's just talk a bit about what happens once you run this particular command. So what happens is the Docker daemon, which is the Docker program which is running on this particular server. What it tries to do first is it tries to find search the image name hello world is there locally. So if it is not there locally, what it does is it will pull from Docker Hub, it will pull that particular image, and then once it is pulled, it will run that particular image, and once it runs, it will exit. So that is what happens here. So let's go back to the slides. So yeah. So now let's just talk about what is a Docker image and what is a Docker container. So images and container are two different things in Docker. So a Docker image is like the template. So it is like a blueprint, or basically what I would like to call it in simple words, like Docker image is like a recipe. So and a Docker container is like your the running version of that image, like your final product, like a cooked dish. So what happens is the Docker program takes the Docker image, looks at the recipe, and then it creates the container, and that is the running instance inside your machines. So basically, the image is like a blueprint, and the container is the running version of that particular blueprint. And for a container lifecycle, so this is how the container lifecycle works. So these are the different stages in a Docker container lifecycle. So once you create the container using Docker run, it either go if there is some error, if there's some problem with that image, there's some problem with that program. What happens is once you run it, it will go to stop state. And if it works successfully, then it will go to running state. And from running state, depending on what the container does. So if it is a database image, then it is running constantly running. But if it is like a program where you wanted to do something and after that it has to exit, then it will just go to the stop state. But from the running state, you can also pause the particular container. Suppose you want to free up the resources for another container or another application. And after that, you can either remove the container. But one thing to keep in mind is that you cannot remove a running container directly. So you should always stop the container before removing it. And let's go back to the exercises. So we ran the first, what we did is we just ran the Docker Hello World container. And next, what we'll do is that suppose we want to have a look at what are the images that are present in our particular server. So the command for that is Docker images. So once you do Docker images, you can see that all the images that are there in full repository. So right now you can see only one image which we just ran, just we downloaded and ran just now, which is the hello world image. And also there is the Docker command to see all the containers. So if you put Docker PS, this will display all the running containers in our particular server. But suppose you want to see only the all the containers, even if it's running or stopped any state, you need to run Docker PS dash A command. So here you can see that 4 minutes ago the hello world container was created and it exited 4 minutes ago. So also something that would be useful for troubleshooting. Suppose you want to debug something, you want something is not working in your Docker, you want to ask ChatGPT that, okay, this is my version of Docker, this is not running. So some of the simple commands would be, if you want to check the Docker version which is installed, you can just type Docker space version, and this will give you the Docker version installed on your the Docker engine version which is installed on your particular machine. And if you want some more detailed information about the Docker system, um, if you're running on a cloud server, suppose I want to see, you can type Docker info, and that should give you more information like the CPU and the RAM. That should be here somewhere. Yeah, CPU here, and how much memory is there on this particular Docker system. So that's something informative. And also, you saw that when we typed Docker PS dash A, we could see all the containers. That's about it with Docker image. And so the next thing what we'll do is we ran our first container. So now let's run multiple containers on Docker. So first thing, let's run Nginx. Nginx is a very popular web server. So we'll be running it. So before that, let's just quickly understand about Docker ports. So you know that like we are working on the Linux system. So when we're working on the Linux system, we're working on the shell. But how are we connecting with the Linux system? So if you see right here on the top, you can see something here on the cloud server. You can see something called 8080. That is basically like a port which is open from the Linux system onto our machine. So that is what is being used for our communication, like all our the command which is sending, the UI which is coming, all that is coming from 80, which is the communication is happening through that particular port. But now, suppose we have a container. So a container is like inside our Linux shell. Suppose we want to communicate with that container. So how do we do it? We use something called as Docker ports. So to use that particular Docker port, there is something called as port mapping. So by default, when we saw the hello world, we didn't run any port mapping. But here, because it is a web server, it has to give us some information. We need to communicate with it. We'll use like the port mapping. So basically, this is the host port and this is the container port. So what I want you to do is first, let us just run this particular command here, and we'll run our first image. So you can see that it's pulling the image, and you should also, I think you should get an error. You should get an error. So that is the error is expected error, because as you saw that the code server using 8080 port, we're already using that port for communication. So this is like a very common error which I always face when I'm working with Docker. So that's the reason it's not working, because we're trying to bind it to an existing port which is already in use. So what I would like you to do is just change that port from 8080 to 8081. And also you need to change the name from Web 1 to Web 2. Because before I was talking about the container lifecycle. So what happens is when a container, when it's created, and once it's started, when there's an error, it just goes to exited state, but the container will still remain. But so there'll already be a container with the name Web1 already existing. So please make these particular changes. So just change the port from 8080 to 8081, and from Web 1 to Web 2, and you should see that it is running. And I'll just explain a bit about what happened. So I spoke to you about the container port mapping 8080 to 8081 to 80. And also, if you don't give a name, Docker will assign its own name, which is it'll be something very funny. You can give it a try. But if you want to give it your own name, you can use the dash dash name flag to give it your own name. And Nginx, that is the name of the image which we are downloading and we're running. And Alpine is like a version of that. And dash D is pretty important. So if you don't run it in dash, you don't put dash d, once it starts running, once you exit out of the terminal, the container stops. So dash d runs it in detached mode. So once you do this, you should see that it is running. And how do we verify it? You'll see there's a new port here, which is available here. And once you click on this little web icon here, you should get a message like "Welcome to Nginx." So that's how you know that your web server is like running successfully using Docker. So can you all please try this? And if anyone has any questions so far. Okay. So now what we did is we ran our first container. So let us run another container. So what I'll do is Apache is another popular web server which is used for hosting PHP applications and even Python applications, but now it's not used so much. So what you can do is you can run this one as well. Just paste the command for Apache. So this runs it on port 8082 with the name web3. You can run this. So it's not able to find the image, it's pulling it, and then it'll run. And if you open it, you can see that it works. So we have two containers running. Yeah. So now let's run the Docker PS command to check what all containers are running. So when we put Docker PS, you can see that there were two containers are running. And you can see the uptime, it's 45 seconds ago and 3 minutes ago when we started running these particular containers. And you can test these containers, but we already tested it with the browser. So I'll skip this particular step. But you can run this command to check if you're getting a response. And also now let's run the Docker images. Since we ran a bunch of other containers, you can run the Docker images command right now, and you can see that there are a few new entries into our Docker images on our local machine. So what happens when something goes wrong? So right now we're seeing when we're running the container, we don't see anything output. We just get the container ID as an output. So logging is very important. So when you run a Python program, how do you know something went wrong with it? You get some error messages in your particular terminal. So similar to that, even Docker has given us an option to see what error messages, information, any sort of logging, so that you can diagnose your problems and you can view the outputs using Docker logs. So now we'll be working on Docker logs. So so what we'll be doing is first, what I would like you all to do is just copy this particular command right here. It is a simple for loop which just sends requests to this particular URL. So you can click on this plus icon right here, like a new terminal icon. It is on the top right corner of your terminal window. Once you click on this, you should get another new terminal. Your previous one should still be there, but you'll get a new one. So what you can do is just paste this particular command right here and click enter. And once you do that, you can go back to your terminal. And then, so once you're pasting it in a new terminal, now let's see how we can view the logs. So the simple command is Docker logs and web2. Once you do this, you can see that there was a bunch of requests being made from our terminal to the container, and this was the response. Recording stop. I think the screen sharing stopped. Where is it? Share. Screen sharing stopped. So yeah, you'll get a bunch of you should be able to see like a bunch of requests over here. And next, now what happened is you saw that it gave us like a bunch of the recent logs. It gave us some logs, and then it's like truncated. But suppose you want to see the logs in like real time. So real time logs are pretty useful to see what is going on, especially with web applications. It's pretty useful to see what like the traffic, web traffic in real time and the LMS in real time. So for that, there is a simple flag called -f, which is like follow. It's called Docker logs follow. So if you do this, you can see that uh, once as you're getting the log, you can see that even the time counter here is like incrementing and you're getting those logs. Yes, Neha. Huh? So now you try the social one. Breakfast is like that. So now we can do the logs. You just go back. It's like a lot of quality. So how we see that? So, yeah, anyone has any questions, or everyone is able to see the like real-time logs? I couldn't understand the difference with the dash without dash F. So, if you don't give dash F, it will just show the recent logs, and it will stop. It will just stop the command. But suppose you want to view the logs in like real time. So if you give dash follow, the logs get streamed. Continuously get streamed. So any fresh logs that come to the container, it gets streamed into the console. Until you press Control. Until you press Control C. So if you press Control C, it will stop. And also you can see that there's a couple of other different logging options. Like suppose you want to view only the last 10 lines of logs. Suppose there are like you have thousands of lines. It's not uncommon to see thousands of lines of logs. Suppose you want to see only the last 10 lines. You don't want to get too overwhelmed. So you can use tail command for that. And suppose here you get the timestamps already in the logs. But suppose some of the logs don't have timestamps, you can just use the -t flag so that it will give the Docker will add its timestamps and it will show the logs with the timestamps. Yeah. Anyway, any questions? So next we'll be moving on to the interactive shell, like how to interact with the Docker container. Yeah. 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 Dash F dash T, we can do that. So let's go with how to interact with a Docker container. So suppose you want similar to how we log in. Suppose you want to interact with your laptop. We use a GUI, but you can also use the command line, which is like a bash terminal or a shell terminal, or in Windows you have something called PowerShell to interact with your computer. You can run commands and you can do different things. But now you may ask, like in Docker, how do we do it? Like when once you run a container, how do we interact with the container? So to interact with the container, there's something called as Docker interactive mode, and there is two main commands for that. So one is run and one is execute. So the only difference is that execute is if the container is already running. So if you can only run it on a running container. If you try to do run IT on a running container, I don't know if it will work, but I think we just create another container, another working container. But yeah, you can. This is on a running container. This is on if you want to start a container and then you want to access the interactive shell. So these are two commands. So let's just go ahead and we will go back to our code server and let us just what this does is it will run a container named Explorer. You can give any name. And we are using Ubuntu. It will open the bash shell in Ubuntu, and dash I is for interactive, and T is, I think, the communication, like terminal. So this is what it does. So can everyone please go ahead and you can run this particular container, like a command, which will create a, so we are working on a Linux container. So it will create a Linux container inside a Linux container and we'll be interacting with that. So So once you do this, you will get, you can see that there's a slight difference in how the our terminal looks. So right now you should get another like different. So this is the user. So what it does is if you don't specify any user, it will run it as a root. So now we are inside an Ubuntu container as a root user. That is we're inside the Docker container already. So we're already now it's running and we're inside the Docker container. So next you can do is some simple command, just you can check the OS if you would like. And after that, you can check if there's any running process. If you check any running process, you can see that the terminal process is running on our Ubuntu container, which you're using to interact with it. And also, what we can do is let's go ahead and inside our Linux container, let us create a file and let us print the contents of that file. So what I'm doing is I'm just creating a file and I'm just printing a container. So from hello from inside the container. So now the file is created. So now what I'm doing is I am exiting the container. So yeah. So what do you think? Now I created a file and I exited the container. Now what do you think will happen to that file? Will the file still be there once you go back to the container, or would the file be deleted? Anyone? Should be there. Yeah. So yeah, that's correct. It will still be there unless you remove a container. Unless the container is physically removed, the data still exists. So that so suppose you're running a Docker image and for some reason it fails, you're not getting the output you want. Just keep that in mind that the logs will still be there inside the container. Suppose you want to troubleshoot. If you remove the container, you lose all the data. So we'll just go ahead and we'll use the start command to start that particular command, the container, and and we will see whether we'll start the container first, and after that we will create the terminal and let's see if the file is still there. So as you all rightly said, I mean you guys are right, the file still exists inside the particular container. So now let's just click exit. So there's also another command. So suppose you're working on your laptop, all of a sudden it stops responding, and you don't know what to do. So what would you normally do? You just hit the power button or restart your laptop. So similar to that, there's a command to restart the Docker container. So it does the same thing. It does the stop and the start. So that is the restart command. You can just do Docker restart and the container name. So once you do it, it will just restart the particular container. And that's about it. So once it does take some time to restart, but yeah, you you get it is restarted. So also, and we can just verify whether it got restarted as well. So you can see that up to 12 seconds. So it got started 12 seconds ago. So it has been restarted. And also, suppose you're deploying an application into Docker. Maybe you have a like a machine learning model you're deploying into Docker. So now you want to see like is the resource are the resources enough? I mean, am I giving too little resources to it, or am I giving too many resources to it? Because when you're deploying on AWS and Azure, if you don't optimize the resources, you can rack up a cloud bill pretty easily. So there's a simple command in Docker to check the resources. So what you can do is if you just type Docker stats, so stats is the command. So once you do Docker stats, you can see that this is the memory usage, this is the CPU usage, and this is the input output, like the network traffic going into that particular container. And yeah. And so this is just one small bonus. So suppose you realize that, okay, see, we have a container here. It is just using 0.02% memory, but we have allocated almost 4 gigs of memory. We've allocated too much memory to this particular container, which can be more useful for some other container. Or you can use this particular command, like the flags for CPU and memory, and you can, limit it. And so what I would like you to try is that I would like you to maybe run this particular container called limited, and you can use the Docker stats command or limited, and you can see the difference. That once you allocate memory. Just so that like if you're still stuck in the root browser of inside the container, just press Control C so that you can. Yeah, or just type exit or just press Control C and you'll exit out of it. So yeah, any questions so far, or everyone able to follow? So what we did was basically we just ran a couple of containers. We went through the entire Docker lifecycle, which is we started a container, we restarted a container, and after that we looked a bit about Docker logs. So Docker logs and the container name is a simple command to check the Docker logs. Different ways you can view the Docker logs. Then after that, we went into the interactive, like interacting, how to interact with the container using the IT command. And after that, now we just looked how to check the resource user stats of the container. So that's what it did so far in this particular module. So moving on. So now, once we did all this, now let us get rid of all the resources. So first, let's see what all we've created so far, all the containers we have run so far. You can just do the Docker ps-a command, and you can see all our containers. So even the hello world container, which we exited 28 minutes ago, you can look at that particular container. And also, what you can do is you can give the container name and you can click stop, or you can give the container ID as well. Or else, what you can to stop the container one by one, or this is a simple command. So what it does is it will stop all the running containers. So you can run this particular command and it should stop all your containers. So basically what we're doing up like after this, we're just cleaning up at the end of the module, we're just cleaning up all the resources. So we can see that there were 3 running containers, those were the IDs, and all of them are stopped. So just to verify again, we can just type Docker ps-a We can see that all of them were stopped, like all of the containers are either exited or all of them in exited state. And to remove the containers, there's a simple command docker rm, similar to the Linux rm command, or else there is something called as a prune command. So there is the prune command is pretty versatile. You can use it for different things. You can prune images using Docker container prune, like image prune, or you can prune the container using container prune. You can prune the network if you create a network, Docker network or Docker volume using container prune. So what you can do is if you just do this, all the containers which are stopped or exited, it will remove it. You can just run this command. It'll click Y, and you can see that all of these containers are deleted. And let's just verify if we everything is deleted. So you should get a blank slate. Yeah. So yeah, there are some bonus exercises as well which you can do a bit later. So these whatever the credentials which were given to you, we won't delete it till the end of the week. Probably Monday or something, I'll delete all this. So if you want to practice on this, you can go ahead and you can still use it. So next we'll be building our own image. So now we were running our images, we'll be building our own image. So we'll just take like a 2-minute break, and then after that we can start building. So there's some donuts and some coffee at the back. Uh, can just grab some and like maybe let's take a like 5 or 10 minute break so we can take a bit a bit longer break, and then once we come back we'll start doing the other stuff. Yeah. Thank you. Resume the workshop. So we'll be starting with module two. So in module one, what we did was we were creating like already there were Docker images on the Docker Hub. So we were just running those. But suppose you want to create your own Docker image. So you want for your own program, you want to customize your own Docker image. So that's what we'll be learning in module two. So we'll be building something called a Docker file. So our Docker file, I told you like a Docker image is like a recipe, right? So the basically the recipe, the recipe list is your Docker file. So Docker uses the Docker file to build your images. So we're just seeing a simple Python, like if you have your Visual Studio, you're executing a simple Python file. Uh, so how do you do the same thing in Docker? So what you would do is first you would need something like a base image. So base image is like Ubuntu, which is a Linux environment. So you have your Linux environment. So what happens is after you have your Linux environment, you take your base image, then you would copy over your particular file, which is your Python file. And Python, you don't need to build it like C++, but suppose you have to build it. So then you will run the whole build process, which is uh, using this particular command, you will make the file. And after that, you would run it using the Python and the Python file name. So this is how you would build a simple Docker file for Python. So basically, it is just instructions for creating the Docker image. And this, what it does is it just automates the entire process for you. You don't have to run all of this manually. So let's go back to our code notebook. Yeah. So here you can file a module 2, and if you just open up the module 2 images, module 2, uh, first what we need to do is we'll create a simple Docker file. So what I've done is I've already created one Docker file and I've already created one file here. So what we need to do is first we need to navigate to this particular folder. So in Linux, you just do this by using the change directory command. Just click change directory and Docker basics. Docker file basics. And once you're inside that particular folder, you can see two files, which is Docker file and hello. So let's have a look at the Docker file first. So it is something very similar. So first, what you're doing is downloading Ubuntu 20.04 version. Then you're just updating all the packages which are there on Ubuntu. And then you're installing curl, which is used for sending requests. And after that, what you're doing is this hello.txt file is there. You're copying that over into the app folder, and then you're changing the working directory. So before you run the command, you need to change the working directory. So similar to how this is the working directory, you are giving a command that you need to change the working directory to the app folder. And once you're doing, you're using the concatenate command. So it just print. So what happens is once you do this, the expected output is that it should print whatever is in hello.txt inside your terminal. So that's what should happen. So if you go to the command, you can see that build and run. So first we need to build our Docker image. So for that, you have the Docker build command. So -t means tag. So you're tagging the image. And so let's build our first Docker image. So once we run this Docker image, similar to the hello world image which we ran initially, uh, you should get whatever is there in the hello.txt file as the output. So you can just put hello from Docker. You can put some custom messages if you would like. You can do this, and you can save it before you do the build. You can change this command here, and it should print that as the output here. So once you run it, you can just click Docker run, and that will run this image. And so you should get the hi from Docker, or whatever message you have put in the hello.txt file, you should get it. So just to because it's a bit important. So what happened is it downloaded the Ubuntu image here. This is what happened here. You can see it here. So it downloaded the Ubuntu image. It ran the command to update, install. It copied the hello.txt file over. It set the working directory and it exported the image. And once you ran the image, it ran this particular command, which is cat hello.txt, which printed this output here in the terminal. So that's about Docker file. And here we also talk about one of the best practices when creating Docker images. So Docker does cache stuff. So there is a cache. So what happens is that when you have a working Docker file, suppose you are making any modifications to it, all the previous layers before the modifications are cached. So only the layers after the modifications they are built again. So the way you arrange your layers, like the commands, is very important. So suppose you are installing requirements. So and after that you're copying your app.py file. So your requirements should always come first before the app.py file because your requirements don't change. So I'll just demonstrate what happens if you don't follow the caching properly. So I'll just so yeah. So here what we're doing is first we are running the command to install curl, and then we are copying the file. So what happens is suppose I just changed hello.txt here. I changed it to my name, and after that now when I build it again, you can see that it didn't take much time. It just you can see here it was cached. So this was cached, and only the file got copied again because the file was changed. But suppose I don't follow like suppose I'm doing copy before I do the installation of the dependencies. So this is similar to first you're copying the your application file and then you're running the pip requirements. So what happens then is you can see when you're running the build, it is building, but you can see that it's installing it again. It didn't get cached. So yeah, it'll take a long time. And some of the requirements, right? If you're installing PyTorch or any big libraries, it takes a really long time. So just keep in mind this order is very important and make sure that you take full advantage of Docker caching. So anyone has any questions with the Docker image, Docker caching, and so next what we'll be doing is we'll see like we'll just go back to we'll just run the Docker images and we can see that our first image like the image which we built, you can see that it is also there in our local repository. And suppose for any reason we lose access to our Docker file, suppose this Docker file gets deleted, and suppose you want to know how this Docker uh, image was built, you can also use the build history command. So you can, if you run this command, you can see the history of how this particular image was built. It will give the exact commands which were run to build this particular image. So now now that we built a very simple like hello from Docker image, we'll be moving on to a bit more complicated image. So we'll be working on a Python image. So for that, what I would like you to do is I would like you to change your directory to this TinyLLM folder. So you can just do this TinyLLM folder. And before we start looking at the app.py file and the Docker file, what I wanted to do is I wanted to build the TinyLLM image. So you can use the Docker build command. So all of you can start the build because it takes a bit of time. So you can start building it, and after that, I'll dive right in. So you can just do Docker build -t tiny LLM or any name you want and the dot. So this will build this image. So this is the tiny LLM folder here. So as everyone was everyone able to start the build process for the tiny LLM? No? Okay. We'll start. Okay. To run the Docker build -t commands build the tiny LLM app. It takes a bit of time, so I just so once you're able to start the let me just talk about this Docker file. So so can I explain? Oh, okay. Yeah. So when we're doing the dot, so the dot basically means the current folder, like all the contents of the current folder. So that is where it will pick up the Docker file from. So suppose your Docker file is in another folder. So what we did is we did a change directory to go to that folder and then we did the build. So if you don't want to do that, uh, I'll just give me a couple of minutes. Let this stop running and then I'll just explain it once more. So yeah. So I'll just explain this image right now. So What we're doing is we're downloading the Python 3.11 Slim. There's also a non-Slim version with a bit more, with more modules installed. So we're downloading the Python 3.11. We're changing the working directory to the app folder in the container. And then what we're doing is first we're updating the Linux. And after that, we're installing these particular packages here. And after that, what we're doing is we are copying the requirements file over, the requirements.txt file, which is here. And then we are installing the Python dependencies, and then we are installing all the packages. After we are installing the packages, so this is important, like we always install the packages first, and then we do the application code, so that, when if we make any changes to the application code, we don't have to run these packages again. And then this is, yeah, so what we're doing is, let me go back to the slide for this one. So this is a Docker best practice. So that last time, I think when we were running the Linux container, you saw that it was running as a root user. So we should never run containers as a root user. We should always give it the minimal permission possible when you're running a container. Uh, because once, if someone gains access to the container, they will only have access to certain parts of the file system, and the entire file system is not compromised. So So how do we run apps as a non root user? So we do that using the user add command. So first we're giving whatever permissions we need. So we're just changing the ownerships, and we're giving read command for this. Only for the app folder, we're giving permissions. We're changing the user to user. If you don't, this command changes the user from root to this particular user. And after that, there is something called as a health check. So Docker is just a program. It just runs your images. It doesn't know whether your images are working correctly or not. So one good practice that it's recommended to do is put a health check. So this is how Docker knows whether your container is running correctly or not. So what it does is you just define the health check, and you give the command which it needs to run. So it will run this particular command. So this is the Streamlit health endpoint. So if this command gives the zero exit code, that means like it is healthy. It's an healthy application, and it will just show the status in your Docker. Or else status one means that some problem is there and it's not working properly. So it is like it's unhealthy. And next, what we're doing is because we were doing the port mapping before, Docker does have like an internal firewall. So you need to expose your application port. You need to open up the application port from within Linux. So that you do using the expose command. And then this is the last command, which when you do Docker run, this is the command that gets executed, which is the Streamlit app. So what I wanted to do is like if the build is executed successfully, uh, 8501 is the port from which the container is communicating from. So what I want you all to do is that you can run your particular Docker image to check if it is working fine. So you can try the command out on your own, but I'll also be putting it here just in case you want to know. So you just do Docker, and what I did is I built my app with the name TinyLLM, the image with the name TinyLLM. So if I go to Docker images, I can see that my TinyLLM app is there. So to run this app, what I will do is I'll do Docker run -d, because I don't want it to run in the background. I want it to run in the background. Then I give the port, and you can give any port you want it to be available on. I'm just giving the same port 8501, which is being exposed. And this is the container port 8501. And then I put my image name TinyLLM, and that's about it. So once you do that, you should you should get this Streamlit app. So yeah, everyone is able to get until this point. Okay, it's a very simple app. So we're just running a small LLM inside Docker. So it's a very small, like it has, I think it is 50 million parameters. It's a pretty bad LLM. So if you can give it a try, you can maybe you can try some stories, but it's not good at all. I mean, it's yeah, it will write some basic stories. So I just wanted to show what is possible to Docker. So I mean, it doesn't do. I mean, it does some job, but yeah. So everyone try it out and try to get this one. Yeah. Can you go back to the command sheet? Sorry. Yeah. Okay. One second. Yeah. Oh, pin now where I'm. Oh, more. I don't know. I mean, I want to hide it. I mean, oh, okay. Thank you. Yeah. Okay. So yeah, if you yeah, this is what I use. This is the command I used. So I built it using Docker build. If everyone is able to build it, and this is the command I used to run it. So on, uh, I think if you just scroll down inside the file as well, inside the module too, you should be able to find all the commands for this. I put it inside. No. On- This is the exercise. Yes. Scroll down. I give it the first image, scroll down. And, I looks like a big exit. I think inside the so now we can see tiny and yeah, 1 minute scans. CV, I think it's where the same thing that our students so we will do okay. Hopefully able to go in and so yeah, so the simple things just to keep in mind. I mean, I'll just repeat once through this. So that what we're just doing is we're just taking the Python image. After we're taking the Python image, we are installing the tools necessary for building the application. And after that, we're copying the requirements file over. So some of the requirements are Streamlit, PyTorch, Transformers library. After that, we're just installing all our requirements. I think the requirements is something else. You can see it, the requirements here. We're installing Streamlit and PyTorch. And after that, what we're doing is once we're installing all the requirements, we're copying the app.py file. After that, we are changing the user. We're giving the permissions for the user only to the app folder so that you know just for security purposes and such that they don't have any modification for anywhere else. After that, we are defining the health check for our Streamlit application. Then we are exposing the port 8501, which is used by Streamlit. And then we are running Streamlit on port 8501. And after that, we are running the container. So this is what we did so far. So yeah, this is the Docker health check. So 0 is healthy, 1 is unhealthy, and 2 is like starting. So the container is still starting up. So based on these particular messages, Docker understands what is happening inside the container, whether it's working or not. Okay. So hopefully everyone is able to run the Streamlit app. If everyone is able to run it. So what you can do is you can stop the container and more. This this gift they want to get off. Then you would say it just refers to like tell them say my name first and that's good. That's good thing of fighting and I've never mentioned. So I was on you first like I was like contacts with some of it. And most of it I just gave it like certain things and I yeah, so I mean that's why it's that's the reason it's like the file is like that. But then I wouldn't use that able to run now? Janet, you are it, huh? What are you for that? The Hindi is all. Full and denied us. No, denied anything. But now, software, that's pretty good. You did build the image. Build it, build the image. Only then you can. So first is building. You need to go to that. But yeah. I mean, go to and then what you do is like Docker build really once it's finished, run the TinyLLM. Run the support mapping, same run the yes. Yeah. Okay. Korean. So, meanwhile, like while the people who are trying to figure it out, when they let them figure it out, while they're figuring out the build and the run process, we can also, look at the, maybe just explore the logs and see what's happening in our tiny LLM app. What is happening with the log? Just to let's check the logs. So let's check the running container, and you have the container ID here, and I can just find Docker logs and the container ID. You can see that, yeah, so you can see like how it was downloading our particular model, which was Distill GPT-2. And you can see that it was generating, it was downloading, and you can see some of the logs here basically. And yep, and that's about it for module 2. So in module 2, we just, we built our own custom Docker image. So next we'll be working on Docker Compose. So suppose we'll go to module 3. So if was everyone able to build the story generator using that, and yeah, Jan, we got it up. No, not yet. Still building up. Okay, I think once you build it, just run it. It should work, or else we'll come back as well. So yeah. So yeah. So, suppose you just go. It's your first day in your new company, and your manager asks you that I have this application. I need one database. Maybe I need yeah, I need one database. I need one backend server. I need two backend servers and one front end server, and I want you all to deploy it in Docker. So normally, what you would do is that normally you can't. you would go and one by one you would do this. Like you would go first, and you will take this one. I mean, you'll take the Docker run for the Postgres, and you will run it. And once you run it, you'll wait for it. And then once this is completed, you'll take your front end server, and then maybe you'll take other requirements based on your application, and you'll run it one by one. So you see, right, how painful that is. And suppose something goes wrong in your Postgres, inside your database, something goes wrong. You need to stop it and start it. But your application depends on your database. So you need to stop your application as well. So first you go, you stop your application, then you stop your database, then you start your database, you start your application. So you can see that, how incredibly painful this whole process is. And suppose you want to share it with one of your colleagues. So what you do is you just copy over this bunch of Docker commands, and you just share it with them and be like, okay, run this first, run this first. So it is pretty painful to do it. So for that, there's one simple sub solution, which is Docker Compose. So let's talk about, yeah, Docker Compose. So what is Docker Compose? So Docker Compose is a single configuration file for managing all your containers. So you can manage multiple containers. Like you have a web application, you have a database, you have a backend. You can manage it in one file. And also, it is very easy to start, stop, or change any of your services from this file. And also, suppose you want to version it. You have a working Docker Compose. You have a working version, something that works. You have a working version of the code. You can save it, and you can create a new version using Docker Compose. And you can also, suppose you want to have two environments. One is a development environment, and you want your production environment to be the same. So what you can do is you can just copy over the same compose file, and then you can just change it to dev. You can just rename it as dev, and you can run it, and it works. So that's the reason we use Docker Compose. So what we'll be doing right now is that we'll be running, uh, I think, yeah. So what we'll be doing first is that, uh, I think many of you would have taken up. I think if you're an ADA student, you would have attended a database class. So for the database class, they'll like Brennbo, he teaches MySQL. So suppose you want to have a MySQL environment set up. So it is pretty difficult to install MySQL. So you download the MySQL file, you run it on your laptop and everything. So suppose now what we'll be doing is we'll be running the same MySQL file. We'll be creating the uh, the UI interface for that. It's called, I think, PHP So we'll be downloading PHP we'll download MySQL, and then we will connect both of them together, and we will see how we can do that using a single file using Docker Compose. So what I want you all to do is, right now you can see that you will be in the TinyLLM directory. So you can go one directory back, and there's a directory called Docker Compose. So I want you to navigate into that directory. You can use the change directory command, Docker. And then inside that you'll have two files. One is your Docker Compose YAML file, and one is your init.sql file. So before that, let's talk about Docker volumes. So was everyone able to navigate successfully to that directory for the Docker Compose? So let's talk about Docker volumes. So previously, what we did was we created one file, and then we could see that if we remove the container, the file vanishes. So that is not acceptable when it comes to databases, because the databases, you might have some valuable information. And if something happens inside Docker, and it causes a container to crash and get removed, you lose all your data. So for that, you have something called as a Docker volume. So Docker volume is basically a persistent storage which is outside your Docker environment. It will sit on top of your virtual machine. And what happens is if anything goes wrong, the data still survives. And also, the next important concept is Docker networks. So what we could see is that using the port mappings, what we were able to do is we were able to communicate with the server with the Docker container from outside the server. But suppose you have two Docker containers the inside Docker. So suppose you want to communicate, you want those two containers to communicate with each other. So what you would do is like similar to being on the same network. Like if you have VPN and you're on the same network, there's something called as Docker network. So you would put both of these containers inside the same network. So what would this allows the containers to communicate with each other. So what we're doing right now is we'll download MySQL. So MySQL image is there, and we're downloading PHP which is the UI for MySQL. So now what we want to do is we want to connect MySQL to PHP So what we'll do is we put both of them in the same network, and also we will mount the volume, the basically the storage for the MySQL outside the container. So that is what we'll be doing there. So I will show you how we can do that. So if everyone has navigated to that particular directory, which is the Docker Compose, you can find inside the Docker Compose directory, you can find two files. One is the Docker Compose YAML file, and one is the init.sql file. So let me explain the Docker Compose file. So it is very self-explanatory and it is very declarative, so it's very easy to read. So what we're doing is basically we're defining the services. We have two main services here, MySQL and PHP So these are our two services. We have one volume here and one network. So the volume is used for the SQL data. So the network is the MySQL network. So we'll be adding both these containers to that particular network. So for MySQL, the image we're using is MySQL version 8. We're giving a container name. And also another best practice is that never hard code any of your credentials. So we use the environment variables, and all of these environment variables sit in this environment file. And what we're doing is we're giving the environment variables here. And once we give the environment variables for the password and username, we are mapping the source. So right now you can see that in our root folder, there is no MySQL data folder. But once we spin up the Docker Compose, you can see that a folder is created. Next, we're also copying over the init.sql file, which is the file here. And next, we're declaring the network, the MySQL network. So this image MySQL will sit on the MySQL network. Next, we're defining the port 3306, which is the default port for MySQL. And also we're defining a health check. So how do we know that, once the database is running, how do we know it's healthy? So what we do is we run the MySQL admin command, ping localhost using the password. And if we get the code 0, that means it's healthy. We will run it for 10 every 10 seconds. And if it and the timeout is 5 seconds, so it will wait for 5 seconds before it timing out. And also this is very important, like the restart command. So Docker has something called as a restart policy. So what happens is you run your database and then you go to sleep. I mean, you're running in a production environment. It is a database being used by many people. You go to sleep. What happens in the middle of the night? Maybe the volume got full, or maybe there's an error inside MySQL, and the container just failed and it stopped. So by in the morning, you might have like tens of emails, like if you're working in a different time zone. So to prevent all of that, what you can do is you can define something like a Docker restart policy. So what happens when the container stops? So the policy is like if by default, if you don't specify any policy, once the Docker container fails, it just stops. So nothing happens. It does not restart. If you put always restart, even if you stop the container, it still restarts. So this is a little bit irritating. You put this and if you're trying to remove the container, it doesn't want to get removed because it keeps restarting on its own. So this is the one I normally use. So unless you manually stop it, it will restart. If it fails due to any error, it will restart. So that is about the Docker restart policy. And yeah. So next is PHP So for PHP similarly, PHP image, name, the environment variables, and this is very important. So before I was telling you, right, previously I was telling you that suppose you have a backend which is dependent on a database. You don't really want the backend to start up before the database and then it tries to connect to the database. It's not able to connect and just throws a bunch of errors. So what you can do is you can specify a dependency. So my PHP it depends on MySQL, and the condition is only if the service is healthy, only then the PHP will run. And it will run on the, and also the same thing. We have the same reset policy. Suppose the container goes down due to some error, it will automatically try to restart, like self-healing, and it is on the same network. So it is important that it's on the same network because PHP needs to connect to uh, it needs to connect to MySQL. So that is about the Docker image. So now let's go ahead. If you open up module 3 exercises, you can find if you've already navigated to the Docker Compose directory. If not, you can navigate. So before you could see that, for every single image, you had to do Docker start image name, Docker start image. But for Docker Compose, just one simple command, even if you specify multiple images, is Docker uh, compose if you're in the same directory up. So if you just do up, it will just start. Dash D is detached mode, so it will run in the background. Like right now, I'm not running it in the background. So you can see once I do up, both these images are not present on a local system. So it is pulling those images from Docker Hub. And after that, it will run. So does anyone have any questions so far? So what we covered is we covered Docker networks, basically to so the containers to connect with to talk to one another. Docker Docker networks, and Docker volumes. So suppose you want the data to be persistent, we have Docker networks, so Docker volumes, and then we spoke about the Docker. So yeah, you should get a you should get this. So if you didn't run with dash D, you can get a bunch of logs. So you can see here that what happened here is that the network got created, container demo MySQL got created, and PHP myadmin got created. And if you run it with the dash D command, so if I just do control C, if I didn't do dash D, it will automatically stop the containers. If I put dash D for it to run in the background, you can see that it is because it's already cached. So it will just give it some time. It will, yeah. So you can see that you can see the status here. So this is the health check which is running. So once the container runs, Docker performs the health check, and only if this health check passes, it runs the next container. And you can see that both the containers are running successfully. And how you can see it is you can go ahead and you can go to 8085 here. You can just click on the globe icon inside ports, and you should be able to get the UI for PHP So yeah, you should be able to get this. So any questions so far? Or if anyone is not able to get to this particular point? So you can also see that how do we know that PHP which is in a different container, it is actually connected with our database. You can actually see our database is right here, and you should see three users, whatever we created in the init.sql file. That should be visible, right? And and also you can also see the MySQL data because we created a persistent volume, like a Docker volume. You should also once the Docker Compose is up, you should be able to see all the SQL data files here. So even if you delete the container, the data file exists. So maybe just to recap, maybe just to just refresh our Docker commands. We can type Docker PS and we can see our running containers. You can see phpMyAdmin. We can see that here. And previously, you could see that suppose we wanted to change any configuration. Suppose I want to add another user into my SQL file. So I am going here. Maybe I'm adding another user here, like Bob Smith. Bob Smith 2 or some Bob 2. So I'm just adding another file. So previously, what we were doing is we had to start the container and stop the container. We had to do Docker stop, and we had to copy the names of the containers over, and we had to start it again. And you can also see like if you specify health check, you can see the in the status it shows healthy on an unhealthy, so it's very easy to monitor the status. So previously we had to stop each container manually, but now because we have Docker Compose, the simple command is Docker Compose and down. If you just do Docker Compose down, it is removed, and like we made this change. So once we do up, yeah, so I mean it starts running. So it's very easy. Like even if you have four or five containers and you want to run all of them at the same time, you can just use the Docker Compose command and it should just work. And also another command is that so similar to how we have Docker logs, we also have logs for Docker Compose. So the simple command is Docker Compose space logs. So if you give the logs, you can see all the log files here. Okay, the dash t flag doesn't work. So yeah, you just give Docker logs, and you can see the logs from inside the Docker Compose, like the file. You can see all the logs being present here. So that is about. And also, we were talking about Docker networks. So how do we see like the different Docker networks? So because we created phpMyAdmin and MySQL on the same network, so what we do is we just run the Docker network command. So you run Docker network and list. If you do this, you can see the network which we created. And suppose we want the another very important command is the inspect command. Suppose we want to inspect a container, we want to inspect a network, or we want some more details about it. So Docker inspect is a pretty handy command which I use. So what you can do is you can Docker inspect network, and you can copy over the network ID which is here or the network name, and you should get some more details about it. So here you can see that the containers in this particular network are demo MySQL and demo PHP MyAdmin. And similarly, if I want to look at the Docker volumes, so I can do Docker volume ls, and you can see that there is one particular volume, which is the volume for MySQL data. And you can copy, and if you want, you can inspect this as well using Docker inspect volume command. And and if I copy over the container ID for PHP admin, I can do Docker inspect container as well. So inspect command is pretty handy to get detailed information. So you can see that the IP address, the internal IP address, and some other details which are present inside using the inspect command. You can it's pretty useful for debugging your errors. So yeah, we inspected volumes, we inspected networks, and yeah, stopping the containers, starting the containers. And also there's some more bonus exercises here as well if you'd like to do it. But was everyone able to, run PHP, MyAdmin, SQL, and get the interface? So we'll be moving on to the final, our last module, which is the interesting, it's a fun module where we'll be actually be deploying our application on the cloud, Docker application. So yeah, so if everyone is through with module 3, let's go to module 4. So for module 4, what you need to do is uh, you can just open up module 4 here, the exercise is here, and the first thing what we'll be doing is we'll be building our image for a big LLM, and like we're making something similar to ChatGPT, but we're deploying it ourselves. So first, what I want you all to do is like navigate into that particular folder. So you can go back from the Docker Compose folder, and I want you to navigate to this particular folder, which is OnRender deployment LLM. So you can do change directory, and you can go into that particular folder. And here you can see that there is a Docker file here. So what I want you all to do is just build this particular Docker file. Just build it using the Docker build command. And if you have any issues, just please like just raise your hand. I'll just come and I'll help you. I don't know. So yeah, so there's once you navigate into the folder, just uh, once you are able to navigate into the folder, you can use the Docker build command. You give your own name. You don't have to follow the same name. Just give your own name, and just once it builds, we'll be going to Docker Hub and we'll be creating our own like Docker account so that we can push our images into Docker Hub, and then we can share that images if share the images with a friend, or if you want to deploy it somewhere, you can deploy the same image. Yeah. So if everyone is able to build this image, what I would all like you all to do is go to Docker Hub, hub.docker.com. So once you go here, let me just sign out. So once you go, there's a sign up button on the top right corner. So you can click on the sign up button. And once you go to the sign up button, you can continue with Google. I like to continue with Google, or else you can put in your username and password. So once you continue with Google, like once you click on this, it will ask you for a username. So that username is what will get, what will be there before your Docker image. So make it something memorable, because any image you create, that name will always be there before that image name. So once you go in and to Docker Hub and you create an account, you should get this particular page. So is everyone able to create their, I think I'll give a few more minutes. So everyone is able to create the Docker account. Yeah, so, um, that's like a bit here and there. So, yeah. No, I think this should be stored. Yeah, yeah, imagine. We're able to create the. Yeah. Is everyone able to create the Docker Hub account, or anyone has any troubles creating this one? So if everyone is able to create this Docker Hub account, this is the important, this is the name which will go before every image. So just copy over this one, like this, the username here from the URL at the top. So, and then you go back to your uh, folder here. And then what you need to do is you need to tag that particular image. So once you've created it, you need to tag it. So, well, no, sorry, before you tag that image, you need to you need to log into your Docker Hub. So what you do is just type Docker and just type login. So once you do login, Docker login, you will get a URL here. What you need to do is just copy this particular URL and you will get uh, this web page. And then there's a code which is given here. You just copy that code. And once you copy that code over, what you need to do is you need to put that code here and click continue. So once you do that, it'll ask for confirmation. And once you do that, you should you should get a message called login succeeded. So was everyone able to log into their particular Docker? Able to log in? Okay, I will log in. Huh? So once you just need to put Docker login. Once you put Docker login, you will get uh, a URL like this. You need to open this in your browser, and you need to put the confirmation code. And once you put the confirmation code, you'll get a login succeeded message once you're able to go to this URL and put in this code. So you just need to do that to log in. Okay. So yeah. So if everyone is able to log in, so the next step is to tag your image. So what happens is in Docker, suppose you have a working version of your image. You don't really want to mess with that, and you just want to create another version. So you always have a working version of your code, just in case something goes wrong. So what you can do is you use tags for that. So you can tag it version 1, version 2, or alpha, beta, you can do it. Or here I'm tagging it as latest, which is the latest image. So to do that, what you do is you would have built your Docker image using a specific name. So I use my personal LLM. You would have built it with a different name. Just in case you forgot, you can just put Docker images, and you can see the the image you created maybe 5 minutes ago. That is the image which you would like to tag. So once you find the name of your the image, what you need to do is just put Docker tag, and I put my personal LLM, my just put your image name, and you can put your tag name, or else you don't need to put your tag name. And you just put in your uh, username from Docker Hub. So you just have to follow the same on line 135, the exact same syntax is here. So I'll go here, I copy my username here from the URL, and I put in my username, and then I put in my image name. So you can give the same image name, or you can give a different image name. It's your choice. So my personal LLM. And if you want, you can give a tag name. So once you do this, there's no output, but you should not get any error. Be able to tag your image. So was everyone able to tag their image? Okay. Yeah. So if everyone was able to tag their particular image, yeah, if anyone has any issues, actually it's really important that we push this image because this is the same image we'll be deploying later. So if you're not able to do this later, we won't have that our working live URL. So if everyone, yeah, you're able to get that. So we'll just give everyone like a couple of minutes so that they'll be able to tag their Docker image. You don't get any message, but you shouldn't get any error. So you're tagged it. You're tagged it. Yeah. So yeah. So something like we tag that image, right? So something similar to like a commit. The tagging is something similar to a commit, but our image is still not pushed into Docker Hub. So for that, we run our next command, which would push our image into Docker Hub. So that is the Docker push command. So what you need to do is just copy the last line, the last line, which is your username and your image name, and you just do Docker push your username and your image name. And so once you do this, you should see that it's pushing the image. So just give it some time. Depending on the network speed, it takes some time to push the image. So yeah. Okay. Yeah. So yeah, once you push this image, you should get a size here. And if you go back to your hub, so if you go back to your app.docker.com, you should get an option for hub here. And when you click explore inside the hub, sorry, not explore, sorry. You go to my hub. If you go to your repositories, hub.docker.com/your repositories, you should see your image in hub.docker.com. Got it? Okay. So was everyone able to the image? Okay. Yeah. Maddie. Okay, I mean, sorry. Yeah. So the next step would be that previously what we did is we deployed our own GPT, which we downloaded. But enterprises, what they normally do, like companies, what they do is they normally use like APIs to use ChatGPT because it's way better and it is faster than hosting your own resources. So what we'll do is to deploy our own LLM, we need is a free API key. So for that, what you need can do is you can go to grok.com, not grok. So you can just go to grok.com. And once you go to grok.com, uh, you can click on developers on the top right here. And you can see there's something called a free API key here. So you can click on that free API key. And once you click on free API key, you should get, uh, you'll get a sign up page. And once you sign up, you should get this particular page. And then you can just go ahead and you can create an API key and you can click my LLM or any name. You can just give your own name for this API key. And once you submit, you should get an API key. So just copy this and just copy it onto a notepad, this API key. So was everyone able to create their own API key? I'll just give it like maybe a couple minutes so that people are able to get the API key. And now, so copy it onto your text notepad or anywhere, just save it for now. We will use it later. So yeah. So once we're done with this, uh, now first we need to you can deploy the image on any platform, but we're using render.com because it is free. They're pretty it's free and they're pretty generous with their free tier. So what I would want you to do is you can go to render.com and just sign up for a free account. So just go to render.com, sign up for a free account, and after you sign up, you should get a page, and there should be an option for deploying a web service. So just do the sign up. You can use a Google account or any account, and wait, laughing at me. So if everyone is able to sign up, then you will get a welcome screen, and I think you should see static site, web services, private services. You should see these options, and you should get a big pop-up. So in that, you need to click on web services. So once you click on web service, uh, you will get something similar to this, like new web service. So is everyone able to get to this point? So once you get to this point, what you need to do is you need to select the source of your source code, which is the existing image. And what you need to do is go back to your Docker Hub and go to your repositories. On the left, there's something in the repositories. Click on your repository for your personal LLM, which you created some time ago, and you go to tags here. And once you go to tags, you will get here, you can see the latest tag. So I want you to copy this tag name here at the bottom right corner. Copy this tag name. And once you copy this tag name, you go back to your render app and you put this in your image URL and you should click connect. So everyone is able to connect. And this is pretty important. So this will be the name of your public URL. So it will be this dot render.com. So just make it anything now personal. So you can just make it, you can, so you can just give any personal name to it. Yeah. Just open your emails and just I think you need to verify your email before you. And that's already. Yeah, okay. And create one. Yeah. Create. Create. So yeah, once you give a name and once you give your account, like I mean the URL and everything. So this is important that you select the free tier. Select the free tier, and then in the environment variables, you need to give grok API underscore key, grok underscore API underscore key, and you would have copied the API key previously, right? So you just have to copy the same API key and you need to paste it in the value here. So we should not hard code any of our credentials. So everything is passed through environment variables. So once you do this, you can just go ahead and you can create the web service. So it is case sensitive. So just make sure that you give the right, make it all caps. So once you do this, you just click deploy. And once you click deploy, just give it 5 minutes and you should have your own LLM running, like similar to ChatGPT. And the good news is that all your data is there because you're using the API key. The data is yours, so you can like private it, something like that. And you can select your models as well on the side. Similar to this, you can also deploy different. This is just a small demo application which we deployed just to show you what you can do with Docker. But you can also deploy any application right now using Docker. Not only Python, Java, Node.js. You can deploy machine learning models. You can deploy your APIs using Python. Sorry, using Docker. You need to go to grok.com and go to API keys. You get free API keys. And once you get the free API key, you need to create the API key, give some name, and you get the API key. So I think that's about it. Once you deploy it and you have the URL available, that is the end of the workshop. Yeah. Thank you. Yeah. So yeah. So let me deploy it as well. So you can interact with it and you can play around with it. If anyone has any issues getting to this point, I can help you out. Yeah, it takes time. It should take 5 to 10 minutes. Go back. Alright. Yeah. And yeah, that should be all caps. CRA. Yeah. Hopefully learn something. Yeah. Thanks so much. Yeah. Thanks so much. I appreciate all the yeah. No problem. Yes. Were you able to get everything working and yeah. Yeah. Well, only the last part where I did put in the API key, but it wasn't working final at all. Okay. Yeah. If you have any issues, you must let us. Of course. Yeah. Thank you. Fine. It's fine. You can add some ways for chatting. You can type some messages, you change the models there. Yes, it's your own private like chatting. I know. It's very useful. Yeah, yeah. Um, Yeah. So how many days it would be valid? This would be, I mean, unless you, it's available. I mean, if Grok decides to, they give them the free API key, right? If they decide to remove that option, only then your application will stop working. But I've been using Render from a year. It's still running, so it'll be running forever. So I built my personal yeah, build your personal. Thank you. Actually. At 23. No, just prompts. And we already built this. This is the UI. This market one. And this is the UI for your actually the UI not the word. It's in the monitor and start messaging there. So you can use. There's only white space. There are really much color. Because yeah, yeah, okay. Yeah, before you all leave, I think Vicky wants us to uh, uh,